So far, we have created a blueprint for creating a node using a self-referential structure. And in this structure, we have our data and our next pointer. And we also type deffed it so that we don't have to type struct in front of node every single time we use it. To the right is a pictorial representation of this blueprint. So whenever we create a node, this is how it's going to look pictorially. We have our data, we have our next pointer, and we also have the address of this node. We also created a pushhead function, one that uses a call by address of the pointer that we set in our main, our head pointer. The other pushhead function we created returns the address to our head node in our main. We've also created a print list function, and this just prints out the elements in our list, and a count node function that counts the number of nodes that we currently have in our list. At this point, we can only add nodes at the beginning of our list. And for this video, I want to show you how to add a node at the end of the list. And I'm going to create a function that does that. So let's get started. The first thing that I want to do is I want to create a function prototype. And I'm going to insert it here after our count nodes function. And it's going to take a node data type so that we can hold the data of our self-referential structure. And I'm going to name this function PushTail since we are adding at the end of our linked list. So for this function, we are going to use call by address, and we are going to use the address of this head in our parameter. It's going to be very similar to our first pushhead function where we take in the address of this head and we create nodes from there. For our parameter, we're going to need a double pointer, which is a pointer to a pointer, and we're going to call it head, and here we're going to insert our data. For our definition, the first thing that we want to do is create a new node using the malloc function. It's actually going to be identical to how we've already been doing it. So I'm just going to copy this and insert it to our function definition. So what this does is we create a new node, we malloc into memory, and this is our error check. Here we insert the data, and here we set the next pointer to null. The same thing that we've already been doing. The next thing we want to do is we want to create another pointer, and I'm going to call it current. And the reason why I am doing this is because I want my head to remain pointed to our first node, and I'm going to use current to do the traversing for our other nodes. And so I'm going to set this equal to head. And don't forget to put your asterisk in front of head. On our first PushTail functions, I forgot to put the asterisk on one of the head because we're using a double pointer to a pointer, and it gave me some weird values when I printed, which were actually addresses. And so now I want to target the first condition. The first condition is if the list is empty. Again, how do we know that the list is empty? Well, head is going to equal null. It's not going to be pointing to anything. So on the right hand side, I'm going to create an activation record in our stack memory section of main. And inside main, we have a head pointer. And I'm going to give this an address of 0x50. And currently, that is pointing to null. We know that our list is empty if our head pointer is pointing to null. For our code, we're going to type the condition if asterisk head is null. Then we're going to set our head to the new node. And so this is how this works. We have our head and it's currently pointing to null. So our list is empty. So what we're going to do is we're going to go to line 132 and we're going to create a new node. And I'm going to give this node an address of 0x100. And so what happens is when we call this function, our PushTail function, and let me create an activation record for our PushTail function. And inside our PushTail, we're going to have our head double pointer, and that's going to hold the address of our head pointer that is inside the scope of our main. So this is going to hold the address of 0x50 because we're calling it as a pass by address. when I actually call this function, and I'm just going to write it, PushTail, we're passing the address of this head, which is 0x50. And let's just say we want to insert 30. In line 132, we create a new node pointer, and we use malloc to create a new node, and we set the address of that node, which is 0x100, to the new node. So this is pointing to here, and that new node is holding the address of 0x100. And then we go to pass our error check, since we should have plenty of memory in the heap. And we assign the data into the data portion of our new node. So in this case, we're going to assign 30 to that data. And then our next, which is this one, is going to be set to null. We go to line 141 and we create a current pointer because we're going to use that current pointer to traverse through our linked list. And we are going to assign head to that. So whatever head is pointing at, that's what current is currently pointing at. Well, right now, head is not pointing at anything. It's pointing at null. And so current will be pointing at null. But once we get to line 144 and we address that condition, if head is null, then we're going to assign the new node's address to head, or we're going to assign new node to head. And so now we have our first node in our list. And since head is now pointing to the new node, our current will also be pointing to the new node. And they will now hold the address of 0x100. For our next condition, if we have a list that currently has one or more node or nodes, and our list is not empty, we want to use our current pointer to traverse to the very last node so that we can add a node after that. Let's address that condition. So we're going to do an else, and this is where we use current. So while current, and we're going to use the current arrow next, does not equal null. And if you look at this condition, our current does not hold the value null. It is holding the value of 100. So our current does not equal null. So what we want to do is we want to traverse our current to the current next. And if that current next has a null value, then we know that we've reached the end of our list. And so our goal is to get to the end of our list so that we can add a node after that. We're going to assign the current next to current. So in short, if our current next is not null, and in this case, it is null, but in the case where it isn't null, we're going to traverse current to the next node. But if this condition is false, if you look at our current and the next value is null, we know that we've reached the end of the list, and we can go ahead and add our new node right here. And so let's go ahead and do that. So once we exit this condition, because our current next is null, the compiler will exit this while loop. And here, after the while loop, we can set our current arrow next to our newly created node. And so let me show a pictorial representation of that to the right. Let's take a look at our current condition. While current next does not equal null. Well, current and then the next, well, it does equal null. So we're going to exit this while loop and we go to line 157. 157, we're going to create a new node. Our new node will now be pointing to that, and let's say the address of that is 0x200. And here, let's call the PushTail function, and let's add 35. So this is going to be 35 based on 139, and the next node, this is going to equal null. But here, our current next is now going to equal the new node. So this will now hold the address of 0x200. And now current will be pointing to our new node, and current will now hold the address of 0x200. So this is how our function will work. Okay, let's add another node so that you can see a demonstration. Let's take a look at this. So our current is currently pointing to this. So while current next does not equal null, it is pointing at null now. And so if that's the case, this condition will be false. And so now we're going to set the current next to a new node. And how do we create a new node? We go through one line to line 133. Let me call the function again, and this time let's add 40. And so we assign 40 to here. And let's just say this is 0x300. So now our new node pointer will be pointing to that. Our new node will now hold the address of 0x300. Then we go to line 145. Does our head equal null? No, it doesn't. So that means we don't have an empty list. And so now we go down to our else condition. Current does not equal null. Well, we go to current.next. But in this case, if we start here, it's going to traverse to the next node, current next. It's going to go to here. And then it's going to traverse to the next node. And once it traverses there, it's going to hit null. So once it hits null, we're going to set this next to the newly created node. So this will now set to that. And so this is 0x300. And let's go ahead and test it. Push tail, and we're going to insert the address of head, and we want to insert 30. So let's compile it. And there it is for our first node, or index 0. Let's go ahead and add another node at the end of the list. And let's just say that this is 35. And there it is. And so let's add 1 to our element 2, or index 2 and third element. Let's add 40. 30, 35, 40. Notice how the node is being added at the end. Now let's go ahead and use our other two functions, because you can use these functions simultaneously, and add a head node. So I'm going to use this first push head function, and I'm going to add 25 to it. So we can just go in increments of 5. The output should be 25, 30, 35, 40. So this should be at node 0. Compile. There we go, 25, 30, 35, 40. Now let me go ahead and use our other push head function where we return an address. I'm going to enter 20 for our data. There it is, 20, 20, 25, 30, 35, 40, 30, 35, 40. And this is our PushTail function.